The other day when we were covering P5, so we left off right here, and I said I wanted you to think about these, and then we didn't actually come back and take a look at these. So I just want to make sure it's clear how to do these in P5 so that you understand some of the things in P6 that we'll take a look at in just a second. So if I were to look at that example 5, part A, let's think about what's going on there. The way we generally did this was we isolated the absolute value, which it's already isolated. Okay, it's already by itself right here. And then we'd remove the absolute value. So I'd write 4x minus 8 and just solve that inequality. And then I'd remove the absolute value and change the sign of this right here. Well, can you change the sign of 0? Nope. Okay. So whether you wrote negative 0 or positive 0, it's still just 0. Both of these you end up solving the same one. So the only way this can be right on 0 is if it equals 0. That's the only way that it can be that far from 0. So the only answer that you get from this is what you get by solving that right there. So you'd move the 8 to the other side. You'd get 4x equals 8. So we get x equals 2. Okay, that's the only answer there. And then if we look at this one, this is a little bit more interesting. Okay, take a look at this, and what it says is the distance that is from 0 is negative 5. The distance that is from 0 is negative 5. Can distance ever be negative? No, so we got a problem right there. The other way that you could think of this is you could say whatever this is, when we take the absolute value, it's going to be positive. And it's saying that it equals, who cares what it is, it's negative. It's negative 5 in this particular case. But will a positive ever equal a negative? Nope, never. So this has no solution. Okay? And then I asked you to take a look at this one right here. Now, we could solve this by doing, by cross-multiplying and all that sort of stuff. But if you look at it, look at the numerators. Both the numerators are x plus 1. So the numerators are always going to be the same. The only way the two fractions could be equal to each other is if the denominators are the same. So you could just solve this one by setting x plus 2 equal to 3 and then go from there. Okay? Now, do we need to be careful with an equation like this at all? It's a rational equation. I see Nathan shaking his head. Nathan, why do we have to be careful there? Yeah, we'd want to be aware of the domain. It just so happens when we move that over, we get x equals 1. It's not this guy right here, so 1 would work. Okay? All right. So let's take a look at and finish up P6, and then I'll do a few questions, and then hopefully everybody got my email. I kind of restated who's doing which of those common mistakes in P7, and then we'll come up here and show those. So this one says graph the inequality, then write the inequality using and or, and choose a test point in order to check this. So we want to find the solutions to this absolute value inequality. This was a less than. We've got the variable part with the absolute value on this side, and it says less than 5. So the word that connects the two of those is an and. We broke it into two separate cases. This one right here, and I recommend that you write it on this side. All we do is we just remove the absolute value, and we're going to solve that inequality. For this one right here, we remove the inequality, but we throw a negative on there. And we realize that when we introduce a negative into an absolute value, an inequality, we change the direction. So that changed to a greater than. So we just solve each one of these, and I'm going to use a different color for each one. So I'm going to add 4. This is going to be x is greater than negative 1. And then if I add 4, this is going to be x is less than 9. And the word that connects the two of these is and. And what did and mean? And means both. Okay, so both of these have to be true at the same time. So if I were to graph this, here's negative 1. Whoops, make that look right. Negative 1. And I'm looking at the answers that are greater than that. So they're on this side right here. Here's 9. So I'm going to put 9 right here. I'm going to circle that, and I'm going to shade the ones that are less than that. Okay, remember looking at these yesterday? Okay, where do both types of shading occur on this? Between the two of them, right? So the way we'd write this in interval notation is we'd write from negative 1 to 9. And what type of brackets, round or square? We're going to do round here. That's how we'd write it as in interval notation. if we were to kind of darken that in, okay, it would have open endpoints and then shade everything in between. If we wrote it as an inequality, we're talking about the x's that are between there. So we're talking about the x's that are greater than -1 and at the same time less than 9. So there's what the graph would look like, and there's the inequality, okay? And then we've got this one right here that was isolated. It's a greater than, and it's the word that would connect the two cases is an or. So again, we remove the absolute value, solve the inequality, remove the absolute value, change the sign of this guy right here, so we change the direction of that inequality. And again, we'll go ahead and solve here. So this is -3x. I'd be subtracting 6, so that's going to be less than or equal to -15. And then if I divide both sides by -3, that's going to give me an x over here and a +5 here. And what do I need to do with that? Switch the direction. So that's got to be a greater than or equal to. Okay. And then, or let's solve this one right here. Move that to the other side by subtracting. That's going to be a -3x greater than or equal to. That's going to be a 3. Again, divide both sides by a -3, and that's going to give us an x, a -1, and we're going to change the direction so that that's a less than or equal to. Okay? So if we were to graph this, here is -1. We'd fill that in and shade that direction, the less than side. And then here's 5. Fill that in. We're talking greater than. Okay? So that's what it looks like as a graph. You can't put the two of these together like you could this one right here and write it as a three-sided or a double inequality is what they called it in this textbook. But we can write that in interval notation. Where do the answers start? Way down here. Remember, we always start on the left end. Where do they start? Okay, so we're going to go from -infinity, and where do they stop? -1. And do we include the -1? We do. So we put the square brackets and then a union, and they start up again at 5 and go all the way to +infinity. Okay? Any questions? Okay. So a couple important things that we didn't get to yesterday would be this example 7. And these are a little bit more complicated. I mean, if we were to graph these, they're more complex graphs. But we can find these on several of the inequalities that we solved yesterday. We picked test points to make sure that we got them right. Well, that's actually how we're going to solve this. In order to know where we're going to pick test points, we need to find something that this textbook calls critical numbers. Okay, so here's how we solve or find critical numbers. If we were solving this and it were an equation, so pretend like there's an equal sign there, what would we do? X squared minus 5x plus 6 equals 0. How would we solve that? Logan? Very good. We're going to factor this. Okay, so if we factor this, multiply to be +6 combined to be -5. So what would do that? -2 and -3. Okay? So here are what critical numbers are. Once you have this set equal to 0, or at least compared to 0, greater than or less than or whatever it happens to be, a critical number is a number that makes the numerator or the denominator of the expression equal to 0. So what would make this one equal to 0? Okay, so this one would be x equals 2, and this one would be x equals 3. Okay, so these are our critical numbers. So here's what we do. We draw a number line, and we put our critical numbers on there, 2 and 3. And then we pick test points in each one of the little intervals that the line is broken up into. So we're going to pick a test point here, we're going to pick a test point here, and we're going to pick a test point here. Okay? Now, here's what I would keep track of. Okay? And a lot of you are probably going to end up being in calculus. Probably everybody here is going to take Math 1050. You do a similar type of thing in each one of those classes. What we're interested in is we're interested in this expression being less than 0. Okay? What type of numbers are less than 0? Negative. Okay, so we're interested in this whole thing being negative. But we broke it up into this factor times this factor. So here's what we're going to do. We're going to pick a number that's less than 2. We're going to pick a number in this little interval right here. Now, what's the easiest one to pick? 0, okay? Now, we're going to plug in a 0. So if we pick x equals 0, all we're going to keep track of is, what's the sign of this factor right here? If you plug in a 0, what do you get? You get -2, don't you? Well, what we care about is that it's negative. And if I plug in a 0 here, it happens to be -3, but what we really care about is that it's negative. What is a negative times a negative? A positive, okay? So is a positive less than 0? Nope, okay? So we don't get any answers there. Let's pick a point in between here. So let's say 2.5. Let's plug in 2.5. If I put 2.5 in this factor right here, I have 2.5 minus 2. Well, that would be 0.5. Is it positive or negative? It's positive, right? So I'm going to put a little plus there. If I plug in a 2.5 into this one, it's 2.5 minus 3. That would be -0.5. Okay? Whether it's 0.5 or 0.6 or whatever, it doesn't really matter. We care that it's negative. What is a positive times a negative? It's a negative. Okay? Is a negative less than 0? Yes. Okay? So this little interval right here works. And then let's check this one. Pick any point you want past 3. Pick any point you want past 3. Plug it in here. What's the sign of this factor? Is it positive or negative? It's positive. What's the sign of this factor? If you plugged in 17, it would be positive. So we end up with a positive here, and is that less than 0? Answer there is no. So of the entire number line, we broke it up into 3 little intervals. What's the only interval that works? Between 2 and 3. So the answer on this one is from 2 to 3. Now the question is, do I include the endpoints or not? So should I do round brackets or square brackets? Brandon, what do you say? Why not? It would actually be, if you plug in a 2, remember what we got here, these are the zeros. This makes each one of those equal to 0. So if you plugged in a 2, this would be 0, the whole thing would be 0. Is 0 less than 0? Nope. If it were an equal to, if it were a less than or equal to, we could include those, but it looks like this, okay? So that would be the answer. So critical numbers are what we get when we compare the expression to 0, and the critical numbers are what we get when we factor the numerator and the denominator. It's what would make the top or the bottom equal to 0. So let's do this one right here. This one's kind of interesting. Is it compared to 0, first of all? Nope. So here's what we're going to do. We're going to move this over. So we're going to subtract 3, and that's greater than or equal to 0. Then I need to make one single expression here. So I need to get a common denominator. So in order to get a common denominator, I'm going to write an x minus 4 here and an x minus 4 here. So I'm going to multiply the top and bottom by x minus 4. So here's what I've got. X minus 4 in the denominator, x plus 2, and then careful here, it's subtraction. That's going to be minus 3x and plus 12. Any questions? And that is still greater than or equal to 0. So all I need to do is put these together. So this is going to be a minus 2x and a plus 14. Everybody okay with that? And then x minus 4 greater than or equal to 0. Any questions to this point here? Okay. I'm going to factor this. So this is a negative 2, and I've got an x minus 7, right? And in the denominator, it's just x minus 4 greater than or equal to 0. Okay, so what are my critical numbers? It's any number that makes the numerator or the denominator equal to 0. And it's already factored. Lynn? Okay, 4 from the denominator, 7 from the numerator. So 4 and 7. So again, what we're going to do is we're going to make a little number line. We're going to put those critical numbers on there. Here's 4, and here's 7. Now, I purposefully skipped something. Whenever we see an inequality or an equation like this, what should we be aware of? It's a rational expression. It's a rational inequality. Let's say this was on the test and you had no clue how to solve it. You could impress me with one thing. You might get a point for saying, you know what? I'm not sure what the answers are, but I can guarantee you one of the answers is not 4. So there's no way 4 will work. Let's keep that in mind, okay? So there's no way x could be equal to 4 in this problem, okay? Pick any number you want less than 4. Easy number would be 0, okay? And let's look at each one of these factors. That's a -2, that's an x minus 7, and that's an x minus 4. So this first one is negative. Let's figure out what the two of these are. If I plug in a 0, what do I get here? -7. If I plug in a 0, it's -4. So if I do a negative times a negative, the top's positive, divide it by a negative, what do I get? I get a negative, okay? So if I plug in something that's less than 4, I end up with a negative. We're comparing this to 0, and we want it to be greater than or equal to 0. Are negatives greater than or equal to 0? Nope. Okay, so the answer there is no. It doesn't work over there. Okay, let's pick a number between 4 and 7. So let's say we pick 5. Now, this number right here is a -2. It doesn't have an x in it. It's not going to change. So that one is negative. Let's figure out what these two are right here. If I plug in a 5, that's going to be -2, or just negative is what we're after. If I plug in a 5, that's going to be positive. So if I have a negative times a negative on the top and divide it by a positive on the bottom, in other words, there are just two negatives in this multiplication division problem, I end up with a positive. And what are we comparing it to? We're comparing it to 0. Are positives greater than or equal to 0? So the answer there is yes. Okay? So we're going to say yes right in there. Okay? And then what about past 7? Let's see what we get there. So again, we've got our -2. We just need to figure out these other two pieces. This is going to be positive. This is going to be positive. I mean, pick a 10, right? Top's negative. Bottom's positive. So this is a negative. And is that greater than or equal to 0? The answer there is no. So, of the entire number line, what's the only little interval that would work here? Okay, so we go from 4 to 7. Now, is there any way we could include 4? Nope. What about 7? Plug in a 7. Let's see what happens. If you plugged in a 7, this would be -2. This would be 0, and this would be +3. You'd have a 0 on the top, you'd have a 3 on the bottom, so that would work just fine. So we'd include that. So that right there is the answer. Again, the important part here is that you compare it to 0, factor it, find the critical numbers, and then pick test points in each one of the intervals. Okay? And this little thing we did here, all we're interested in is the sign of the answer. Is it positive? Is it negative? So we call that a sign line. Any questions there? Okay, let's take a look at this one right here. Luckily, this one's a little bit easier. Can somebody tell me why this should be a little bit easier? What's that? What'd you say, Tony? You sure? What can we do with this? Yeah, we could factor it. What could we take out? We can take out a 4. What else can we take out? X squared. If I take out a 4x squared, I'm left with an x and a -3, and that's comparing to 0. It's got to be less than 0. Okay, now let's think about this for just a second. We need the critical numbers. Need the critical numbers for this. So we want to know what would make each one of these factors equal to 0. What makes this factor equal to 0? 3. And how about that one right there? Okay. For some reason, that's a weird one for a lot of people. What would make x equal to 0? Well, 0 would make x equal to 0. So here's our number line. We're going to check 0, and we're going to check 3, and pick test points for each one of those. Now, here's the cool part of your thinking. That number is a 4, a positive 4. That first factor, if you want to think of it that way, is always going to be positive 4, so it's not going to change. Can somebody tell me something interesting, unlike the previous problems that we've done, something interesting about this factor right there? What is it, Noah? It's always positive. Whatever number you plug in there, it's going to get squared, so it's always going to be positive. The very smallest it would be 0 if we plugged in a 0. So that one's going to be positive. Okay? And this one right here. Let's pick a number that's less than 0. Pick any negative number you want. What's the sign of this factor? It'd be negative. So I have a positive times a negative. So I get a negative out of this, and I want to compare it to 0. Are negatives less than 0? Yes, they are. So we've got a big yes here. Plug in any number you want here. Again, I don't even have to check the first two factors because the first one's positive. That one's going to be positive. Let's just check this one right here. A number between 0 and 3. Say you plug in a 2. What's the sign of this factor right here? Negative. So the whole thing is negative, right? We're comparing that to 0. We get a big fat yes on this interval. Okay? And then this one over here, again, this one's going to be positive. The second one's going to be positive. And if I plug in a big enough number, anything bigger than 3 and subtract 3 is going to be positive. So I get a positive. Are positives less than 0? The answer there is no. Okay? Now, here's what we've got to be careful with. Is it everything from negative infinity? Look at all these yeses, all the way up to 3. Or do we have to be a little bit careful here? What happens right at 0? Okay, it equals 0, right? It's not less than 0, it equals 0. Okay? So if we were going to write this answer, here's usually how we'd do it. We'd go from negative infinity all the way up to 0. We wouldn't include 0. And then we'd start up again at 0 and we'd go to 3. Now, do we get to include the 3? Nope, because that would make it equal to 0 also. Okay? So there's the answer. Okay, any questions? What's that? Oh, let's see. So I'm going to hit that, and then I'm going to do it a lot slower. This program, if you circle something really fast, it means you want to get rid of it. So, all right. Any questions? Okay. Last type of problem from P6. Okay. And let's think about this for just a second. We want to figure out what the domain is of each one of these expressions. And we've talked about the fact that you can't divide by 0, and you also can't take the even root of a negative. So that's an even root. So I want to make sure that whatever's underneath here is at the very smallest 0 or positive. So if you think about it, the domain would be when x squared minus 4 is what compared to 0? Greater than. Or equal to. It could equal 0. That would be just fine. Okay. Does anybody know what that graph looks like? It is a parabola. Very good. Okay. We'll talk about that in chapter 1. We'll review that, make sure everybody's aware of that. Okay. Does anybody recognize that if we factored it? It has a name. Difference of squares. So this factors to x minus 2 and x plus 2. So what are the critical numbers on this? 2 and negative 2. Okay. Would 2 and negative 2 be included in the answers? Peyton says yes. Why? Yep. Because if you plug those in, it equals 0, and it says it can equal 0. So you're going to include those. Okay? So basically you're going to do a number line. Here's negative 2, here's 2, and then you're going to do the same thing we did up above. Everybody okay with that? Okay. Let's take a look at the next one then. Whatever this is, x plus 2 over x minus 4 has to be greater than or equal to 0, right? What are the critical numbers? Okay, 4 and negative 2. So on our number line, we're going to have negative 2 here, 4 here, and then again, you're going to check each one of those. But we need to be just a little bit careful about this. What do you know about 4 and or negative 2? You have to be careful with either one of those? Which one? 4. There's no way the answer could include 4. So we might want to mark that down to begin with. There's no way our answer interval can include a 4. Okay? Any questions? Okay. So let's do this. Had a couple people ask some questions. So I'm going to add a page to this, and we're going to look at, so we'll look real quickly at number 49. So 49 says this. It says absolute value of x minus 5 is less than negative 1. What do you know about absolute value? Especially when you compare it to negatives. Absolute value is always positive. Is a positive ever less than a negative? Nope. There's nothing you can do to make that true. That's never true. We say there's no solution. Okay, so on 49, there's no solution. Do you see why? Okay, all right. You don't need to write this down, but I do want you to watch. Okay, the absolute value is isolated. It's a less than, so the word that comes between these two inequalities is an and. Take the absolute value off. Solve that inequality. Take the absolute value off. Change the sign of this one. In other words, multiply it by a negative. That's going to make it a positive one. What do I do with that inequality? Change it to a greater than. Okay, you don't need to write this down. You can just watch. Okay, I'm recording this, so if you wanted to go back and watch it again and take notes, that'd be fine. I want you to watch and think. Okay, I'm doing this exactly like we did the other ones. Okay, so I'm going to go ahead and solve this. I'm going to add 5 to both sides. That's going to be less than 4. X is less than 4. This one, if I move this over, this is going to be x is greater than 6. Then I'm going to graph these. Okay, here's 6. Says x is greater than 6. Here's 4. Says x is less than 4. Okay, what's the word that connects these two inequalities when we've got a less than like this? And. What does and mean? Both. Whatever is part of the answer has to have both types of shading. It has to make both of the inequalities true at the same time. We also call this an overlap. Is there any overlap here? Are there any numbers that would be greater than 6 and at the same time less than 4? Nope. So you can see there's no solution here either. Okay? So even if you did it the old school way and didn't think your way through it like this, there'd still be no solution. Okay? Any questions? All right, let's take a look at the next question. If we went in line, would be number 89. So here's number 89. It says 2x squared minus x minus 6. And it says find the critical numbers. Okay, so do we know how to find critical numbers now? You bet. How would we do it on this one? You have to factor it, right? Now, if you can't quickly think of the numbers that would go here and here to factor it, do the trinomial grouping technique. Multiply these together, that's negative 12. I'm looking for two numbers that multiply to be negative 12 and combine to be negative 1. So negative 4 and 3. They multiply to be negative 12, they combine to be negative 1, and then rewrite this way. And then use grouping on this from here on out. Okay. Let's see, a 2 here and a 3 here will do it. This one needs to be negative and that one needs to be positive. Okay. So what's the critical number that comes from this one? Okay, critical number here is 2. Critical number here, remember we talked about this last week? Opposite of that number right there, opposite of the constant divided by the coefficient, so negative 3/2, negative 1.5. Okay? Any questions? Okay, next one on the list, if we went chronologically or numerically, would be 103. Let's take a look at 103. X squared plus 8x minus 5 greater than or equal to 0. This is awesome because this is just like the one that we did, and you were asking questions about stuff I hadn't covered yet. So that's great. I appreciate the questions. Do you know how to solve it now? What do you find? Critical numbers. Multiply to be negative 5. You do. You have to do the quadratic formula. Okay? That might be a calculator problem there. So the critical numbers would be negative 8 plus or minus big square root 64 minus 4 times a times c. So that's going to be a 1 and a negative 5 all over 2. Careful right here. 64, am I adding or subtracting? I'm adding 20 in this case. So the two critical numbers, 84, one of them would be negative 8 plus radical 84 over 2, and the other one would be negative 8 minus radical 84 over 2. And I would use a calculator for that. Okay? Get the decimals for those, locate those numbers on the number line, and then plug points in. Okay? All right. Let's see, 113. Okay. All right. Based on what we've talked about today, what would make this equal 0? What would make this one equal to 0? 1. And what would make this one equal to 0? Negative 2. Both of those are part of the answer because they actually make it equal to 0. Okay? So those also serve as our critical numbers. So I've got a 1 and I've got a negative 2. Let me move these around so we got more space. This looks like it should be worse than some of the problems we've done. Why is this, why should this be a relatively easy problem? Now that you know how to do it, not making fun of anybody for asking a question on this, but take a good look at it. What do you notice about this right here? Okay, it's already factored, so that's great. We didn't have to factor it. What do you notice about this factor right here? Very good, Logan. It's always positive. So that first one is always positive, and then this is going to be whatever it is cubed. So you could go through and you could fill it out like this. We already have most of the sign line done for us. All I need to do is figure out whether this is positive or negative. And what happens if you cube a positive? Stays positive. What happens if you cube a negative? Stays negative. Okay. So whatever the sign of that factor is, that's going to be the sign of the whole factor even when you cube it. So let's plug in a number that's less than negative 2. Let's say we plug in a negative 7. Negative 7 plus 2 would be negative 5. The big deal is there it's negative. So this is going to be negative, and then we want that to be greater than or equal to 0. Negatives greater than or equal to 0? Nope, so this part doesn't work. Okay? And then you can finish it from there, can't you? Okay. All right, and then the last one we'll take a look at is 141. So go ahead and flip the page over on 141. Ooh, a story problem. Let's see. Okay, so it says you can rent a mid-size car from Company A for $250 per week with unlimited mileage. So from Company A, it just costs $250 a week, right? Doesn't matter how far you drive. A similar car can be rented from Company B, but it costs $150. So it's cheaper up front, and then 25 cents a mile. 25 cents a mile. 25x. Thank you very much. What did you say, Tammy? 0.25. Okay, so if this is in dollars, this would represent $25 a mile right here. What do I need to do with the two of these to get the total cost for this rental? Add those together. Okay, so this one's a flat rental fee of $250. This one's $150 up front. If you don't take it anywhere, you don't owe them any more than $150. But for every mile, they're going to charge you 25 cents. So if you went 4 miles, they're going to charge you another $1. It would be $151. Everybody see that? Okay. And then it says this. How many miles must you drive in a week in order for the rental fee for Company B to be greater than Company A? So for this rental fee to be bigger than this rental fee, so 150 plus 0.25x compared to 250, the only question there is, do you put a greater than or less than? And it says, doesn't say less than or equal to, greater than or equal to, it just says we want this one to be bigger than this one right here. So what symbol would go here? A greater than, okay? And then you can solve that, right? Okay, any questions? Okay, excellent.